Okay, here we go. Page 27. Brooklyn, page 27. So remember that tomorrow you guys are going to write a quiz on everything we've learned about exponents, including the very first day where we talked some about square roots and cube roots. So that's happening tomorrow. So today we'll continue doing some more work, and we're not going to learn anything new. This is uh, based on what we learned last week on simplifying expressions involving exponents by using those laws of exponents. Okay? It might not be a bad idea to have a little cheat sheet made up that just has those laws of exponents on them so that you can always refer back to it. Now, you can't use it for the quiz tomorrow, but we're going to be using these as we go through not only this chapter but also the course. Why are you late? Keaton, right? Why are you late? Okay, well, you need to be to class on time. Okay? Because if this keeps happening, there'll be an email home, and then if it continues happening after that, it'll be down to see an administrator. Thank you. Page 27 in your package. Get it out, please. Okay, so looking at question A, it says simplify and evaluate where possible. So where the evaluation part comes in, if the base is a number, then we can evaluate. We can get an answer. And sometimes we'll use our calculator to do that. But we need to go and use the laws of exponents. And you should have seen this in the past that you always do what's inside brackets first, right? We have a order of operations that we always follow when we're doing multiple operations. And you remember the word BEDMAS, BEDMAS. So this can be used to remember the order of operations, and the B stands for brackets. You always do what's inside brackets first. Then if there's any exponents, you deal with those next. Then you divide and multiply from left to right. Then you add and subtract from left to right. So that's what BEDMAS means. It tells us the order that we need to do. Keaton, put your phone away. The order that we need to follow when we have multiple operations to do. And again, the B is brackets. We do what's inside brackets first. And inside the brackets, we're multiplying two powers with the same base. So the law says that we add the exponents and keep the base the same. So it is going to be 0.6 as the base, which will stay the same. And then you're going to add the exponents together. So we'll get 3 plus negative 3. And then that's all raised to the power negative 5. Now inside the brackets, when you add 3 and negative 3 together, they cancel and you're going to get 0. So we get 0.6 to the power 0. Remember, the base stays the same when you do this. And we learned before that anything to the power 0 is 1. So this becomes 1 to the negative 5, which is still going to be 1. Okay? 1 to any power will always equal 1, even if it's a negative power. But just to show you why that's true, if I write it like that, 1 times 1 to the negative 1, and I do that because this negative 5 needs to be made positive by moving it from the top to the bottom, but we need something left on top, so that's why I have that 1 there. So when you move the 1 to the 5 down to the bottom, it becomes a positive exponent, and 1 to any power is still 1. This is 1 over 1, which is 1. But you didn't even have to go do those last couple steps because you could have gone straight from that to saying it's 1. It doesn't matter. Okay? Question B. Again, inside the square brackets, you're multiplying powers with the same base. The base is t. Well, the law says that you add the exponents and keep the base the same. So it'll be t to the power negative 4 plus 3. Right? The law says when you're multiplying powers with the same base, you add the exponents and keep the base the same. And so when you add those exponents together, negative 4 plus 3 is negative 1. base stays the same. And now you have one exponent raised to another. The law says you multiply the exponents. Keaton, you need to be copying this down. You multiply the exponents and keep the base the same. So -1 times -3 is +3. There's our final answer. We can't evaluate that because the base is a variable, a letter, not a number. But we've simplified it. Question C. Inside the brackets, you're dividing powers with the same base. Cherry, do you remember what you do to the exponents there? When you divide powers with the same base, do you remember what you do to the exponents? And what happens to the base? Yes. Subtract the exponents and the base stays the same. So 6 take away 4 is what we need to do. Now, I don't expect you to write this step that I just wrote there. I mean, I'm pretty sure you all know that 6 minus 4 is 2. So that'll become x squared to the power -2. Now what do we do, Declan? Multiply the exponents. Yes, because you have one exponent raised to another. And what happens to the base? Stays the same. So you'll get x to the -4. 2 times -2 is -4. Are we done, Sal? Why not? Okay, we can add a coefficient of 1 there. And what happens to the x now? It goes to the bottom. And when you move it from top to bottom, the exponent sign changes. We always have to leave our answers with positive exponents. Right? So there's the final answer for question C. Question D. Inside the big square brackets, what I would first do is you've got y squared to the power 0, one exponent raised to another. The law says you multiply the exponents, keep the base the same. Really, it's the same thing on the bottom as well. So that y is y to the 1. So you're going to multiply the exponents and keep the base the same. So this will be y to the 2 times 0, which is 0, over y to the 1 times 3, which is 3. Keaton, what's y to the power 0 equal? No, not 0. Can you help him, Princess? Anything to the power 0 is 1. Now, that is true, but I'm going to leave the y to the 0 there because my next step is we're dividing powers with the same base. So what do we do there, Jensen? When you divide powers with the same base, what do you do to the exponents? Yes, and what happens to the base? Stays the same. So 0 take away 3 is -3. But then you also have an exponent -3 outside the bracket. What do you do to the exponents now, Liam? Yes, absolutely you do. Whenever you have one exponent raised to another, you multiply the exponents and the base stays the same. And -3 times -3 is a +9. So now we don't have any negative exponents to worry about. Okay, you could have said y to the 0 is 1. That would have been 1 over y to the 3. And you would have got the same answer in the end. You would have. Okay, it doesn't matter. No matter which way, you'd get an answer of +9 there. Okay. This example shows how we can use our laws of exponents to help us figure out a problem. It's estimated there are 117 billion grasshoppers in an area of 39,000 square kilometers of Saskatchewan. Approximately how many grasshoppers are there per square kilometer? So, 117 billion. That's 117 with 9 zeros. 6 zeros means millions. You need 3 more zeros to get to billions. So that's what that number is. And that's divided by 39,000 square kilometers. Okay, we want to know how many grasshoppers there are per square kilometer. Right? So that means that you have to have your grasshoppers on top, your kilometers on the bottom. That's why I did it in that order. The number of grasshoppers per square kilometer means grasshoppers on top, square kilometers on the bottom. So that's why I wrote it like that. Now, I'm going to use scientific notation here so that I can write these as powers. Okay? So you might remember normally with scientific notation, there's two parts to it. The first part is normally a number between 1 and 10, and then it's times 10 to some power. That's normally how scientific notation is done. Now, I am going to change it a little bit here, and I'll show you why I'm going to change it a little bit when we get it written down. I'm going to write 117 billion as 11.7 times 10 to some power. And that power is the number of spaces the decimal has to move from where it is right now, which is at the end of the number, to between the second one and the 7, because I'm writing it as 11.7. So to get 11.7 here, I have to move the decimal 3 places, plus 3 more is 6, plus 3 more is 9, plus 1 more is 10. So in scientific notation, that is 11.7 times 10 to the power 10. And that's going to be divided by 39,000, which I'm going to write as 3.9 times 10 to the power 4. And where that 4 comes from is that's how many decimals you have to move from the very end to get to the space between the 3 and the 9, 3.9. And now we're dividing these two. Keen? So this is why I wrote that top number as 11.7, because I'm going to divide the numbers in front. I'm going to divide 11.7 by 3.9. See, had I gone to 1.17, then the number on top would have been smaller than the number on the bottom. By doing it this way, now the number on top is larger than the number on the bottom. So I'm going to use my calculator, and I'm going to divide 11.7 by 3.9. Can someone do that on their calculator? Mine is asleep right now. It doesn't want to wake up. What's 11.7 divided by 3.9? Exactly 3? Okay, thank you. So when you divide those, we'll get 3. And now we're also going to divide the powers. 10 to the 10 divided by 10 to the 4. We're dividing powers with the same base. So we can subtract the exponents and keep the base the same. 10 minus 4 is 6. What are you shushing about? So there's our answer. Our answer is that there are 3 times 10 to the 6 grasshoppers per kilometer squared. And if you wanted to write that in expanded form instead of scientific notation, that times 10 to the power 6 means you have to move the decimal to the right 6 spaces. Okay, Brock? Put your phone away, please. Calculator? Oh, I'm sorry. Okay, so right now the decimal is after the 3. We need to move it 6 spaces to the right. So that's going to be 3 zeros plus another 3 zeros, or 3 million grasshoppers per square kilometer. Okay? So there's the answer. So you see, we can use scientific notation, and then we can use our laws of exponents. Right? Now, obviously, you could have put in the original numbers in your calculator and divided them out. You get the same answer. But this just shows you some of the other applications of the laws of exponents. Right? And this next one is done the same way, except it wants you to state the grasshopper density, which again is based on the number of grasshoppers per square meter. Now, in this case, we are told that there are 401 million grasshoppers in 25 square kilometers. So let's write that out first. 401 million grasshoppers in 25 square kilometers. If you divide those numbers right now, you will have the number of grasshoppers per square kilometer. But the table, the chart, wants to know how many grasshoppers there are per square meter. So we have to do a little bit of work here to figure out how many square meters there are in 25 square kilometers. If you were just going from kilometers to meters, you'd multiply by 1,000. There are 1,000 meters in a kilometer. However, we're not going from kilometers to meters, we're going from kilometers squared to meters squared. So to make that conversion, instead of multiplying by 1,000, we have to multiply by 1,000 squared because area is in units squared. That is the reason why we have to multiply by 1,000 squared. So let's do that on our calculator. If we go 25 times 1,000 squared, that gives us that gives us 25 million. That's what that becomes. So now I have 401 million divided by 25 million. Meters squared. So I can write meters squared at the bottom where above it was kilometers squared. So obviously we could take our calculator right now and we could put those two numbers in and divide them and we'd have our answer. But I'm applying what we've learned about laws of exponents here. So I'm going to write both these numbers in scientific notation. And in this case, I can write the top number as 4.01 times 10 to some power and divide it by 2.5 times 10 to some power. Because the number on top, 4.01, is greater than the number on the bottom, greater than the 2.5. So now we just have to figure out what those exponents are, right? And right now, in both cases, the exponents are at the end of each number. We need to move them for the top so that the exponent is between the 4 and the 0. So we need to move it 3 spaces, plus another 3, which is 6, plus 2 more, which is 8. So that becomes times 10 to the 8. On the bottom, we're going to move it 3 spaces, plus another 3 is 6, plus 1 more, which is 7. We'll take our calculator, we'll divide the 4.01 by 2.5, and that gives us 1.604. One 1.604 times 10 to the 1. And if you multiply 1.604 by 10, you'll get 16.04. So that's how many grasshoppers there are per square meter, which means that the infestation is severe because that number 16.04 is between 12 and 24 grasshoppers per square meter. So the infestation would be classified as severe. So again, at the bottom there's all the laws that we've been talking about. So again, it wouldn't be a bad idea for you to make yourself a cheat sheet that you can always be referring to. You won't be able to use it on the quiz tomorrow, but as we go through more questions, whenever you see exponents, you could refer back to that just to remind yourself what the laws are. Okay? So they're there for you. All right, on the next page, there's a slide. Circle the step where an error was made. What do you think, Keen? Where was the error made? Can you see the error? Anyone see the error? Yep, Sal? Right. When you go 0.4 minus negative 0.6, a minus minus becomes a plus positive. So their mistake was in the very first step. When you divide powers with the same base, the law says you subtract the exponents. And what happens to the base, Keen? It stays the same. So it should have been 9 to the power 0.4 minus negative 0.6. The minus minus becomes a plus positive. 0.4 plus 0.6 is 1, so it's 9 to the 1, or just 9. So there's the correct answer. So their mistake was in the very first step. All right, so some more examples where we simplify, write all answers with positive exponents. Kai, what do we do for the first one? What do we do to the exponents? And what happens to the base? Absolutely. Because you're multiplying powers with the same base, the law says you add the exponents and the base stays the same. So it's x to the power 7. Riley, what do we do for the second one? And what happens to the base? Yes, stays the same. Some of you might want to say that the base is 1 because you're saying, well, isn't y divided by itself 1? And that is true, but that's not what the law says that we need to do. The law says we subtract the exponents and the base stays the same. 8 take away 3 is 5, so there's our answer. What do we do for question C, Cheney? And what happens to the base? Stays the same. So what is our answer there, Cheney? A to the what? Right. Don't forget that A, the last A, is A to the 1. You have to add a 1 when you're adding the exponents. Question D, Chloe. What do you do to the exponents? Say again, sorry? And what happens to the base? Stays the same. 2 times 4 is 8. So there's the answer. Question E, Sophia. What do you think we do there? So what would you write as your answer as far as your first step here? So what do you do to that coefficient of 2? Well, you do, but let's write it like this. We'll do another step. You have to distribute the power to every part of the inside. That includes the coefficient of 2 as well as the m cubed. And that's where you're going to multiply the 3 times 2, the exponents. But 2 squared does mean 2 times 2, which is 4. Every time you see a power 2, you multiply the number by itself twice. In this case, it's the same result as if you're multiplying 2 by 2, but the power 2 really means you're multiplying the number by itself twice, because 3 squared is not 3 times 2, it's 3 times 3. 4 squared is not 4 times 2, it's 4 times 4. Right? Olivia, question F. What do you do? And what happens to the bases? Stay the same. So for x, you're going to multiply 2 times 5 and get x to the 10th. For y, you're going to multiply 3 times 5 and get y to the 15th. There's your answer. So far, we haven't seen any negative exponents to worry about. That's coming up with this next question. What do we do for question G, Peyton? Okay, so you're actually adding the exponents, and so 2 plus negative 5 is the same as 2 take away 5. So that'll give us x to the negative 3. And what happens to the power 3 when we move it from the top to the bottom? It goes positive. There's the final answer. Cannot leave answers with negative exponents. Question H. What do we do first step, Emery? Subtract what? The exponents. What's the exponent on this first u? There's nothing written there. Yeah, it's 1. So when you go 1 take away 6, you're going to get negative 5. Is that our answer, Brock? Absolutely, good. Right, you cannot leave the answer with a negative exponent. This u to the negative 5 is technically 1 times u to the negative 5 because we need something on top. We can't leave it blank. Excellent. Emil, what do we do for question I? Subtract the exponents. So it'll be negative 7 minus negative 2. The minus minus becomes a plus positive. So it's negative 7 plus 2, which is negative 5. Are we done, Brooklyn? Lorenz? What else do we need to do? Okay, we can put a 1 in front because that technically is true. And now what? Good. Move the r down to the bottom. The exponent sign changes from negative to positive. Keaton, what do we do for question J? Add what? So what would you add together? So what would you get when you add those together? So you're not really adding x squared and x to the 5th. You're not really doing that. Your answer is correct. You're adding just the exponents. And the base stays the same. You're not adding x squared and x to the 5th together. That's not what you're doing. You add the exponents. 2 plus 5 is 7. So finish it off, Keaton. What is the exponent on y going to be? Well, it's negative 8, but it's right in front of you too on your page, right? Might be easier to read it there, maybe. Say again? Y to the negative 5. Is that right, Keen? Good. So far. We're not done yet, though. Okay? What else do we have to do here, Keen?
You need to put the x7 on top.
X to the 7 on top?
And y.
Because I asked you, that's why. Why do you got to be like that?
So funny.
I know. I know. What's left?
You gotta put y negative 5 on the bottom. That's gonna be positive 5.
Yes. Okay? And I showed you last week why this works. Okay? I split up the 2. I put them both over 1. I moved the y down to the bottom. Then I went back and multiplied them together. You don't have to do all that. I showed you how that works. Question K. I would simplify the top first. I would simplify the bottom, and then I would divide. Okay? Because there's separate brackets for top and bottom. Okay, Cheney? If it was one bracket for the top and bottom, then you would work inside the brackets first. But that's not the case here. Separate brackets on top and bottom. So we need to simplify the top and the bottom first, and then we can divide. So if we simplify the top, Kenzie, what would you do? Sorry? Well, we've got exponents on the inside, raised to powers outside. What do you do to the exponents when you have one exponent raised to another? Multiply them, yes. So it's a to the 4 times 3, which is 12. B to the negative 2 times 3, which is negative 6. Over. On the bottom, this a is a to the 1 times 2 is a squared. And then for the b, 3 times 2 is positive 6. So there's our first step. Multiply the exponents together. And so now we'll divide. Jensen, how do we do a to the 12 divided by a squared? How do we do that? Subtract what? The exponents. And what happens to the base? Stays the same. So 12 take away 2 is 10. And when you do the b's, negative 6 minus 6 is negative 12. So that's where we're at. Are we done, Brooklyn Dryer? What else do we need to do? Say again? And so what would it look like? Okay, good. Negative exponents have to be made positive. Now, looking at question L, you're really dividing two powers here with the same base. The base is 3b. The top one is 3b to the 1 divided by 3b all to the 4 on the bottom. So we can use our laws of exponents to simplify this first by subtracting them and keeping the base the same. So that'll become 3b to the power negative 3. 1 take away 4 is negative 3. What now, Brock? Okay, it's actually a b, but yes, absolutely. 1 would stay on top, 3b on the bottom, and now the exponent sign changes to positive 3. Yes, absolutely. So, Keem, what would we do to simplify this further? Is there anything we can do? Anything else? Sure, we can. We can raise the 3 inside the bracket to the power 3 outside. That means 3 times 3 times 3, which is 27. And then we're also going to cube the b. Okay? So we can do that. Question M. So you got some smaller brackets or rounded brackets inside the big square, and then power 2 on the outside of the big square brackets. Remember, BEDMAS says we do what's inside brackets first. So I would simplify inside the big square brackets first here, because I'm multiplying powers with the same base. If you multiply the x's together, it's x squared times x to the 1. That'll give us x cubed. When you multiply the y's together, it's y to the 1 times y to the 4. That'll give us y to the 5th. And when you multiply the z's together, you add the exponents again. 3 plus 4 is 7. So that's all raised to the power 2 outside. And on the bottom, we can simplify this. We've got 3 powers inside the bracket raised to the power 3 outside. In each case, we multiply the exponents. So it'll be x cubed y to the 6th z cubed. So I simplified the bottom completely. I started simplifying the top, but I got one more step to completely simplify the top. And that would be that now I'm going to multiply the exponents on top, because I've got exponents inside the bracket raised to exponents outside. So x to the 3 times 2 is 6, y to the 5 times 2 is 10, z to the 7 times 2 is 14. X cubed, y to the 6th, z cubed. Brock, I hope you're copying all this down, eh? Okay. Haven't seen your pencil move on your paper for a bit now, but what's the answer then? Yeah. Okay. That's great. That's awesome. I appreciate that. But just try and keep up, okay? This is important. So now what do we do to finish this off, Sal? Subtract the exponents. And what happens to the bases? Stay the same. So when you divide the x's, subtract the exponents. 6 take away 3 is 3. When you divide the y's, subtract the exponents. 10 take away 6 is 4. And when you divide the z's, subtract the exponents. 14 take away 3 is 11. So there's our final simplified answer. Okay? Yes, there's more. Isn't that awesome? Because if I didn't, you'd go home and complain to your parents. I wanted more. He wouldn't give me any more exponents. I know that. But we won't do all these, okay? We won't do them all. Let's do question K, though. I would work inside the rounded brackets first and simplify by dividing. That's what I would do there. Okay? So, first step. Peyton, you need to put your phone away. You're right, it is your bad, but I'm going to let it slide this time. What's our first step for question K? Say again? Put it as a power of 2. So I would probably simplify inside the brackets first. Your way would work, but I think my way is going to be a little bit simpler. It's going to take less work to do it this way. So I would work inside the brackets first. What do you get when you divide x to the 4th by x? Yes. And how'd you get the 3? Subtract the exponents. So what will the power on the variable y be? Yes, because 3 minus 1 is 2. And that's all to the power 2 times. So when you do the same thing for the second bracket, 5 take away 2 is 3, and 4 take away 2 is 2. So there's first step. Now what, Cherry? I asked what your middle name was. That's nice. Second question, what's our next step here? I wouldn't. Right, exactly. Yes. So when you have x cubed squared, you multiply the exponents and get x to the 6th. Y squared all squared is y to the 4th. X cubed all cubed, again, multiply the exponents, get x to the 9th and y to the 6th. And then, yes, absolutely. Now you'll multiply the x's together by adding the exponents. Multiply the y's together by adding the exponents. There's the final simplified answer. Okay, let's switch over to question N. Question N. You're dividing top by bottom, and that includes the coefficients. 16 divided by negative 4 is negative 4. So Declan, how do we divide b to the 5th by b to the negative 3? What do we need to do there? That's right. So when you go 5, take away negative 3, the minus minus becomes a plus positive. It'll be 5 plus 3, which is 8. What about the b's, Cherry? I'm sorry, the c's. What about the c's? What do we do? And get what? You're subtracting. Negative 6 minus 3. Yes, negative 9. So there's where we are. Are we done, Allie? Why not? So what do we need to do? And what would the final answer look like? Keen, is that negative 9 or negative 4, excuse me, in front? Is that a problem? No. You can have a negative coefficient. You just can't have a negative exponent. You have lots of problems, Keen, but that's not one of them. Okay, let's go down to question P. Sophia, what do we do? Add the what? Exponent. So what will the top become? Yeah, because you're adding 1 and 11 together. That m is m to the 1. Now what, Riley? So a to the power 4. Final answer. I'm sorry. M. I think I was looking back at the previous question. The basis of a. All right. So I'm going to make a deal here. If Princess gets question R correct, we'll be done for the day. But if not, we might have to do a few more examples. Do you want to take a minute and work through it? And everyone should be doing the same? Everyone work through this one, see what you get. And then Princess is going to walk us through. And if she's right, we'll be done for the day. If not, we'll do some more examples. Can I give you a hint? Don't overthink it. You're welcome. Didn't need to be working through this. See if you get it. No, not everyone will. Only about half the people. Yeah. So what'd you do first, Princess?
Okay, so I multiplied the exponents.
So what'd you write?
8, -4, and then 3/16.
Like that?
Yeah.
What happened to the 3? What happened to the 3?
What 3? There's a 3. It's gonna be -9.
That would be -9?
Yo.
Oh, we're doing R?
No.
I was doing Q. Okay, give me a minute.
Oh, you were doing Q.
Yeah, I was doing Q. Hold on.
Okay. Yeah, take your time. It's no problem. Bell's not going to go for another 15, 20 minutes. No, more than that. Almost a half hour. So we got a half hour.
Okay. 3 to -2.
Uh-huh.
8 power 4 -8. And
Okay, hang on. Let me fix these because I wrote down what you told me to last time. So this is power 4 and that's -8. Okay, now what?
then positive 8.
I'm sorry. You said +8. Yep, absolutely.
You're making me.
Oh my god, this is almost right earlier. Oh my god.
Now what? Anything? Are we done?
No. Okay, now you have to.
What happens to the 3 to the -2?
I'm gonna. Oh my god.
It just magically disappears?
No.
Oh.
You're gonna. How do you
Well, I
multiply?
already gave you a hint about that.
You're gonna multiply or something?
Don't overthink it.
I was doing fine, and then you okay. Okay, so you 3 to the power of -2 is nine.
No, it's not. You cannot evaluate with a negative exponent. You have to make the exponent positive. How do you make that -2 become a positive? You put it on the bottom, yes. Well, I told you I don't know how many times not to do that.
Why would you ask?
Keen, what's 3 squared? What is 3 squared?
9.
Yes.
No. So good.
There's the final answer. Okay? There's the final answer. Now, there's an assignment there that you're going to do and you're going to hand in. It's just that one page. Okay, so you're going to rip it out of your package. You're going to put your name on it.
For Mark?
Yes, it counts for marks. If you didn't hand in the one from last week, so Stanley, I don't have page 21 from the package from you. Page 21. You need to get that done and hand it in. Jensen, you told me last week you were going to hand it in and you didn't. And Chloe, I don't have yours either. Page 21 in your package. So this one here, page 33, is also due for marks. And you have your quiz tomorrow on this stuff. Okay? All right.